Firm's expansion path. Suppose you have Q is equal to KL. Okay, this is your production function with you. What is the MRTS L for K in this case? It is given out to be MPL by MPK. This is the ratio of marginal product of labor to marginal product of capital. What is the marginal product of labor here? That is del Q by del L upon what is marginal product of capital? Del Q by del K. Okay, that would be minus del Q by del L would be Y minus. Right now there is no need for minus K by L. And suppose W is the wage rate, R is the rental rate of capital. Okay, so your cost minimizing input combination would be at a point where W by R is equal to K by L. Fine. So given your Q, which is equal to KL, I can write this as, instead of Q, I can instead of K here, I can write L W by R equals to K. I can write this Q equals to L W by R into L. Now, further suppose W by R is equal to 1 by 1, which is equal to 1, and you want to produce, say, 10 units of Q. So 10 would be equal to L into W by R, which is 1, into L, which is L square equals to 10. Fine. So L is equal to root of 10. What is K equals to then? W by R into L, which is 1 into root of 10, which is again root of 10. So K is also equal to root of 10. Fine. So what happens is when you want to produce, you want to produce when Q is equal to 10, and your input prices are same, that is 1 1. Your cost minimizing input choices are root 10. So this is what you have got. Fine. And in case if you want to find the isocost line, you can also find that is C is equal to WL plus RK. Okay, but when W and R, they are both equal to 1, so it is just equal to L plus K. C equals to L plus K. So supposedly for a given level of W and R, supposedly initially this is my isocost line. Fine. And corresponding to this is my isoquant, which is producing Q equals to 10. And corresponding to this, I have the amount of labor and capital with me. So here my labor is equal to root 10 and my capital is also equal to root 10. Now supposedly what happens is that I want to produce a higher amount of Q. Say Q equals to 20. Fine. Everything else is unchanged. But I want to produce Q equals to 20. Fine. So what will happen is that at Q equals to 20, supposedly here my Q is equal to 20, but I know this that Q is equal to L W by R into L according to all this formulation. Now I want to produce Q equals to 20. So that would be L square into 1 because W by R is 1. So L is equal to root of 20. Similarly, you can also prove that K is equal to root of 20. So when you want to produce Q equals to 20 at the same input prices 1, 1, your cost minimizing input choices became root of 20, root of 20. Okay. What will happen is that your ISO cost line, it will go out. Fine. Or should I say that? Say for example, you have initially you have C is equal to WL plus RK. Fine. So I'll write here C equals to WL plus RK. Clear? I can write this as C minus WL equals to RK. I can also write this as K equals to C by R minus W by RL. Fine. Now, I know this, that my W by R is unchanged. Fine. My W by R is unchanged. So, K is equal to C minus L. Because R is 1, W by R is 1. So, K is equal to C minus L. Fine. And in case if I want to produce root of 20, K and L as 20. So, my C actually has to be equal to 2 root 20. Fine. In case when my K was equal to root 10, it was root 10 minus is equal to C minus root 10. So in that case, my C was 2 root 10. Fine. So my ISO cost line was basically 2 root 10 is equal to L plus K. Now in this case, my ISO cost line is 2 root 20 is equal to L plus K. Fine. Now this line will shift parallelly to this point. And corresponding to this line, I have an input choice, which is Q equals to 20. Fine. Now, both of these corresponding to this is my Q equal. Let me just write it with this at this point. At this point, the amount of labor is root of 20, amount of capital is also root of 20. Okay, both of these, this E1 and E2, they are the input cost minimizing input choices, okay, for a given level of Q. Now in case if you join these two together, you get what is known as firm's expansion path. Fine. So for each Q, this firm's expansion path, it finds the input choices that minimizes the cost of producing Q. If input costs, they remain constant for all amounts, we can easily trace out this locus of cost minimizing choices. Okay, so this is your firm's expansion path. Generally, you will assume that this is an upward sloping firm's expansion path. Okay, but it is not necessarily so. In case if one of the factor is inferior, then you would, after a certain point, you would want to consume less of that factor. Fine. But we are not going to talk about it right now. This is the firm's expansion path. Firm's expansion path is, what does firm do? Firm wants to minimize its cost. Okay, to produce a given level of Q. It needs to find out the cost minimizing bundles for each level of Q. When the input prices are unchanged and you trace them, okay, and input prices are unchanged, and you find the cost minimizing input choices for each level of Q, and then join them together, what you get is firm's expansion path.